Hi, and welcome to the third video in our Serverless DevOps series. In our first video, we deployed a simple serverless web application and used Serverless Framework to manage and debug it. In our second video, we built the same web application using Serverless Microservices and began exploring Serverless Framework's serverless.yaml file for building services. In this video, we'll put together what we learned in the past two videos to create a new Serverless Microservice from start to finish. Our objective in this video is to learn how to create a new serverless microservice from scratch. To accomplish our objective, we're going to build a serverless RESTful web API. This service will add a missing feature to our already existing web application. This is the current architecture of the application we're working with. There's a front-end website hosted on S3, a back-end for requesting rides, and a service to manage dispatching available rides from the fleet. But we're missing a key feature. We don't record any rides. How are we supposed to perform basic work such as billing or even analysis on the rides that we serve? We need to add a new service that records the rides we serve up. That service is called Wild Rides Ride Record. After the ride request Lambda function makes a request for a member of the fleet, but before it returns a response to API Gateway, it should send data about the ride to the ride record service. This is what our new service we need to build looks like. A request is sent to an API Gateway endpoint, and it'll trigger a Lambda function that has permission to record the ride data to DynamoDB. Before we create a new service, let's take a brief look at Serverless Framework templates. When creating a new Serverless Framework project, a template is required. You can use a built-in template, a template URL, or a template directory path. Serverless Framework has basic templates for different languages and serverless platforms. You can see a list of the available built-in templates by typing slscreate-help. Here, in the help, we can see the list of available templates. I've gone ahead and created my own template, which lives on GitHub, for AWS Lambda and Python 3.6 that's more opinionated than the built-in template. I created this to automate some repeated changes that I regularly make. I've standardized the project structure. Handlers is where I put my function handlers, and tests is where I put my service testing. Among the files of note in this template are my requirements.txt files contain modules I typically need at runtime and during development, and the package.json file lets me use Node.js's npm to install Serverless Framework plugins and do some additional initial project setup. This is my template serverless YAML file. The service key will be overwritten when we create a new service. The plugins key has a single plugin listed. This being a Python project, it makes sense that I want a plugin that manages our functions dependencies. Come down to the custom section below. I have a standardized way that I handle setting the deployment stage, selecting AWS credentials, and setting function logging levels. The deployment stage lets us have dev, QA, prod, etc. deployments of the same service. The stage to be used can be set on the command line, set as an environmental variable, or the default value of dev will be used. Next is selecting the right AWS credentials profile. This may not be necessary for you, and just using your default AWS credentials may be enough. However, I additionally segregate my deployment stages into different accounts, which means I need to switch credentials periodically. I can specify what AWS credentials to use via the command line, environmental variables, or finally fall back to the default credentials, which should be fine for most people. Finally, I occasionally need to toggle the log level of my functions. To do that, I've added an environmental variable I can change from the command line. That variable value is passed to the Lambda runtime environment and checked by our function handler, as we'll see shortly. Come down now to the provider key. Here's where we define the services for AWS and uses the Python 3.6 runtime. Next, we set the stage and profile keys with the values from the custom section above. Below that, we set the log level in the Lambda function runtime. Finally, stack tags is where we define common AWS resource tags in a service. Come down to the functions section. This just shows how I expect functions to be defined. The Python function should be in the handlers directory. The name of the file and the name of the function resource should demonstrate an obvious relationship between each other. In this case, they're both named action. And finally, the Lambda entry point should be the function named handler in that file. Now that we've had a look at our template, let's initialize our ride record service. To do this, we type SLS create -n, where we give it the name wild ride record, -p with the name of the directory to create the service in. We'll name the directory the same name as the project, and finally -u with the URL path to our template up on GitHub. Now we change to the newly created directory. Once there, we run npm install to install the Serverless Python requirements plugin defined in the template serverless.yaml file. Next, we run npm run setup. The project template I've created and use will create a Python virtual env, enable it, and install some dependencies. With the new project initialized, the ride record service needs the resources shown here. The service needs a Lambda function that's triggered by an HTTP post request to the record endpoint on API gateway, and that function has IAM permissions to write to a DynamoDB table. Let's also take a moment and look at the data we'll be sending to our API endpoint. We're expecting a JSON document that should have a unique ride ID, a unicorn from our fleet with a name and color, and the time of the request. That web request will in turn look like this to the AWS Lambda function when it's passed from API gateway. You can see the request path, method, and headers. Right now we just care about the body down here at the end. You'll see the JSON doc sent in our web request will be escaped into a string. Keeping a test event along with a new serverless project is really useful. You'll see this file come up again later. Now we'll open up the serverless.yaml file for this service. We'll start by giving it a quick description. Next, you can see the service keys value is the name we gave Serverless Framework on the command line when we initialized this new service. The rest of this file is exactly like the template file that we saw earlier. Instead of starting with our function, we're going to start by adding our DynamoDB table. We need a unique way of identifying the data in the table. That's called our hash key. We'll use ride ID as our hash key, and we're going to define it here in the custom section. Come all the way down to the bottom of this file where we'll add the resources section. This is where Serverless Framework lets us define additional AWS resources besides functions. Everything in this section will be standard CloudFormation. This is our DynamoDB table. DynamoDB is AWS's NoSQL database offering. For us to create a table, we need to define a schema and table hash key. As mentioned before, our hash key is ride ID. I've added the attribute definition which defines ride ID as a string, and then I define it in the key schema as the table hash key. Below that, we've defined the provision throughput for the table. The read and write capacity unit values define the amount of simultaneous reads and writes the table can handle. We'll set this to 5 for now. Another time we'll go over auto-scaling this table. We'll head back up to the provider section now. Our function needs the ability to write to DynamoDB. We add an IAM role statements key and add a statement providing the ability to write items to the table we just created. Notice the line that says fn getAt. We don't know the Amazon ARN of the table ahead of time. The fn getAt function will get that for us. Down in the function section, we're going to replace the template function. We'll start by giving it a descriptive name, post ride record. Down in the handler line, we'll change that to the handler function inside the post-ride-record.py file in the handlers directory. We gave the function a description and left the memory size and timeout values alone. Below that, we added the environment key. We need to tell the function what DynamoDB table to work with. We defined an environmental variable called ddb table name, which we'll see later is checked by our function. On the line below it, similar to the getAt function we saw earlier, we use the ref function to get the name of our DynamoDB table. Lastly, we define the event that will trigger this function. As mentioned earlier, our service takes an HTTP post request to the /record endpoint. Defining that here will create an API gateway endpoint that, when called appropriately, will trigger this function's execution. Lastly, we need to add a stack output. In particular, we'll want to output the endpoint that we make the record request to. We're going to need that so ride requests knows where to send data to. We're going to call this output ride record URL. For the value, we construct a URL based on API Gateway's naming standard. Frustratingly, there's no easy way to get this value from CloudFormation. The export section is where we make this value available to other CloudFormation stacks. At this point, we're now all done in the serverless.yaml file. Now we can go ahead and code the function. Go into the handlers directory. Copy the action.py file created by the Serverless Framework template to put riderecord.py. And once that's done, let's open it up. We'll start by giving the function a brief description on the first line. To work with DynamoDB, we'll import the Boto3 module, which is the official AWS SDK for Python. Now we'll add our DynamoDB setup. We perform this work outside of the handler function because we only want to do this work once. After the first invocation of this function, subsequent invocations of it won't need to do this setup until AWS recycles the underlying container. What we've done is gotten the DynamoDB table name from the runtime environment. We configured this to be passed in while we were in the serverless.yaml file. Below that, we create a DynamoDB resource object. And then we create a table object. Through this table object, we'll add records to the table. Step into the handler function. The first thing we need to do is get the ride data from the event that triggered this function. We'll pass the function event to a getBodyFromEvent function that will soon write. And we'll assign the ride data to the variable rideRecord. Below that, we'll add a function called putRideRecord, which will pass the rideRecord variable to. This function will write the ride record to DynamoDB. We need to return a response to API Gateway. This information is then returned to the HTTP client that made the request. We define an HTTP status code and a JSON document to return as the response body. With our handler written, let's add our two new functions. getBodyFromEvent takes the invocation event and returns the HTTP request body from it. putRideRecord will take a ride record and insert it into DynamoDB. We see the DynamoDB table resource that we created earlier being used to do this. This is the extent of our function to record ride request data. If this was a production system, we'd add more things like error handling, but this is enough for now. With our function coded, we do SLS deploy-v to deploy it. Our brand new service is now fully deployed, but we still need to tell the ride request service to send ride data to this service. Down in the stack outputs, take a look at the ride record URL value. We're going to update the ride request service to obtain and use this value later. Let's test our new service really quickly. We'll start by using Serverless Framework's invoke command. We'll invoke the post-rideRecord function with the test event that we saw earlier in this video. What we get back is the response that we expected. Next, we're going to test both the API Gateway and Lambda function together by posting data to the API Gateway endpoint. It's possible for a Lambda function to be fine, but have the API Gateway integration fail. Using curl, we get back the API response that we were looking for. We need to tell the ride request service to send ride request data to the ride record service. For these two services to communicate with one another, the ride request service needs to know the endpoint of the ride record service. To solve this problem, we'll make changes to the serverless.yaml file and do the exact same thing as we did for finding the ride fleet service. We'll create a key in the custom section of the file, and its value will be obtained by a lookup to CloudFormation. Come down to the function section then, and in environment, Add a new key called ride record URL. Now that the request ride function knows where the ride record service is, it's time to update the handler in order to use it. Go ahead and open up the function handler. Start by adding a line to obtain the ride record URL value from the runtime environment. We'll now add a function called _post_ride_record. Its first argument is a Python dictionary that contains ride request data. The second argument is a URL and it defaults to ride request URL. The function itself is pretty basic. It uses the request library to send an HTTP post request to a URL. The ride argument will be converted to JSON and sent in the request body. Down here in the handler function, we add a line to call post_ride_record. The single argument we'll pass it is the ride request data that we would send back to the client requesting the ride. We'll go ahead and deploy the newly updated ride request service. We use the familiar command sls deploy-v. With everything deployed, we can head over to the Wild Rides application. Select a pickup point and request a ride. In the DynamoDB service in the AWS console, refresh the items in the table. Our new ride has been recorded. Congratulations! You've now just created your first serverless microservice from start to finish.